Hi, don't forget to check out my course for the Quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail. Alright, so that brings me to the last question of CAT 23, the first lot. Please pause the video and try it out, and you can resume for the solution. Alright, so the question says a lab experiment measures the number of organisms at 8 am every day, starting with 2 organisms on the first day. The number of organisms on any day is equal to 3 more than twice the number on the previous day. If the number of organisms on the nth day exceeds 1 million, then the lowest possible value of n is. Okay. So there are multiple ways of trying this question out. You can start by finding out the number by brute force. You can start by listing down the values on every particular day. A slightly better way is to observe a pattern in here. So we'll see that. Look at day one. On day one, we have exactly 2 organisms. Now the question says on day 2, this number gets doubled and 3 gets added to it. So double of 2 will be 4 and 4 plus 3 will be 7. So on day 2 we have 7 organisms. Likewise on day 3 also the number doubles and 3 gets added to it. So 7 2s are 14 plus 3 will become 17. Likewise on day 4 the number doubles and 3 gets added. So 17's double is 34 and 3 is 37. And on day 5 the number again doubles and 3 gets added. So double of 37 is 74 and 3 is 77. Right? So as I've said previously, one way is to manually write down all the numbers and check where we reach like 1 million. Okay, 1 million is like 10 lakhs. So basically we have to check manually where the value reaches 10 lakhs or 1 million. Okay. But here, as I've said in the beginning, we'll start by looking at a pattern here. Okay, so first thing I want you all to observe is the difference of all these numbers, right? So 2 and 7, the difference is 5. 7 and 17, the difference is 10. 17 and 37, the difference is 20. 37 and 77, the difference is 40, right? Look carefully. If you look carefully, you will realize that all these numbers are basically multiples of 5. So 5 is actually 5 into 1, right? 10 is basically 5 into 2. And 20 is basically 5 into 4. 40 is basically 5 into 8, like so on and so forth. Now the interesting thing about these numbers is I can write 2 as 2 raised to 1. So this 5 into 2, 10 is actually 5 into 2 raised to 1. Similarly, this 5 into 4 is actually 5 into 2 raised to 2. Likewise, the next number 5 into 8 is 5 into 2 raised to 3. And the first number 5 into 1 is 5 into 2 raised to 0. 5 into 1, if you subtract 3 from this, you get the number of organisms on day 1, that is 2. 5 into 2 raised to 1, that is 10. If I subtract 3, I get the number of organisms on day 2, which is 7. Similarly, 5 into 4, 20 minus 3. If I subtract 3 from 5 into 4, I get 17. That is the number of organisms on day 3. Same way, 5 into 2 raised to 3 is 5 into 8, 40. If I subtract 3, I get the number of organisms on day 4. So now we start to see a pattern. On day 1, the number of organisms is 5 into 2 raised to 0 minus 3. On day 2, the number of organisms is 5 into 2 raised to 1 minus 3. On day 3, the number becomes 5 into 2 square minus 3. On day 4, it is 5 into 2 raised to 3 minus 3. Right? So whatever is the day, okay, the power of 2 is 1 less than it. Okay, so 2 raised to n minus 1. So on the nth day, on day n, the number of organisms will be 5 into 2 raised to n minus 1. From this, I'll subtract 3. Okay, that's the number of organisms on any particular day. Now, if you substitute n is equal to 1, you get this value, that is 2. If you substitute n is equal to 2, you get this value, we get 7. If you substitute n equal to 3, you get this value. N equal to 4, you get this value, so on and so forth, right? So we have figured out that on the nth day, these many organisms will be left. Now, as per the question, this number should be greater than 1 million. 1 million is what? 10 lakhs. So adding a 3 on both sides, well, that's pretty insignificant though. We get 5 into 2 raised to n minus 1 will be greater than 10 lakh only. Adding a 3 will not make a huge difference. So keep it as it is. Divide by 5 on both sides, I get 2 raised to n minus 1 will be greater than 2 lakh, right? So that's how it is. 2 raised to n minus 1 will be greater than 2 lakh. Now this is where I would need the help of the on-screen calculator. So guys, notice that when you take the value 2 raised to 18, 2 raised to 18 is 2 lakh something. So if 2 raised to n minus 1 is more than 2 lakhs, obviously n minus 1 must be at least 18. Then they're asking you the lowest possible value of n. The lowest value of n minus 1 we have found is 18. So the lowest value of n will be 19. And this is the answer to our question. The value of the organisms exceeds 1 million on day 19. Right, so very beautiful question, lengthy and tough, yes, obviously. But if you have prepared the questions based on series, and incidentally we have also solved a few questions like this in our course as well, then it should be a doable question for you. Otherwise, you'll have to struggle and write the numbers manually and try to get the answer. Least possible value of n is 19.